All right, so we were finishing this problem, right? We found the first derivative, and let's see, let me catch up to where we are. So that's the first derivative here, right? This one's only a first derivative question because it says increasing. Okay, so we're done with finding derivatives. We're done with derivatives. Okay, so to find increasing, we have to do critical values, right? We have to find the critical values. So to find the critical values for this guy here, what do we need to do? What do we have to do to find the critical values for this guy? Set it equal to 0, right? And more specifically, the top equal to 0 first, and then the bottom equal to 0. Okay? So let's do the top first. So the top, so negative 2x e to the negative x plus 3 e to the negative 2x and then minus 8x squared e to the negative 2x equals 0. Okay, so that's the top. That's the numerator. Well, as crazy as that looks, it is a trinomial. It is a trinomial. It's got 3 terms. 1, 2, 3. So to solve a trinomial, we're going to use the same steps we've been using. Set it equal to 0. Done. Is there a GCF? Is there something that they all have in common that I can factor out? Hmm? Yep. They all have that guy there. And if I take those out, it becomes a more familiar problem, because then it's negative 2x plus 3 minus 8x squared. That's just a quadratic. Okay, so let me change it around a little bit. So let me change this around. So I have negative, I'm going to put it in descending order so that it looks a little bit more what I'm used to. Okay. Also, I have, there's a leading, the leading term here is negative. When you're factoring, you want to make sure that the leading term is positive because it makes the rest of the process easier. So what I'm going to do here also is I'm going to factor out a negative too. So that's going to change this to positive, and this to negative. So a negative 1, factor out a negative 1. Okay. Then I'm going to factor. So I'm looking for the two numbers that multiply to be negative 24 and that add to be 2. Are there two numbers that multiply to be negative 24 and add to be 2? Mm-hmm. 6 and negative 4. Now, because this guy is because a term, or the leading coefficient, because this right here is not 1, I can't just put positive 6 and minus 4 here. Okay. If it was 1, if this guy was 1, going back to math 2 and math 3, if this guy was 1, then you would just have x plus 6 and x minus 4. Be done. But it's not. So I have to do a little bit more factoring. So one way to do it is using the multiplication box, kind of the reverse multiplication box. So we put the first term here, the last term in here, positive 8x squared, negative 3. And then the two terms we came up with. The two terms we came up with were 6x and negative 4x right here. Because together, they have to make positive 2, positive 2x. So that's why they get x's as well. So now we're going to do the opposite. What did it take to multiply to get those guys? Well, I need an x here. I need an x here to get x squared. Let's see. I could go negative, oh, wait, let's see. 4x here, -1, and I need a 2 and a +3. So what I'm trying to check to see is if these guys multiply to make what's in the box. So let's double check. This times this makes this. This times this makes that. It's like a puzzle you have to kind of figure out backwards. And that times that makes that. Okay. So that's what's going to go over here. 4x plus 3, 2x minus 1. Okay. Set everything equal to 0. Set everything equal to 0. You have 3 things you got to set equal to 0. You have this. We have this. And then we have, let me move this over here. Okay. Well, the 2 on the right are just linear. So just subtract 3 from this guy, add 1 to this guy. Divide by 4 over here, divide by 2 over here. And 1/2 here. Okay. This guy over here, well, I can divide by -1 to get rid of the -1 in the front. So I have e to the -2x still equals 0. So you can do this. There's an algebraic way, but there's probably the easier way is just to think about it. Is there any way, is there any number you can think of that when I plug in here and do the power, it's going to be 0? Let's plug in 0. If I plug in 0 here, right? That's e to the 0 power. What is e to the 0 power? It's still 1. It's still a value, right? It's not 0. So is there any way for me to make a 0 using a power? No, there's not, right? There's not. There's no number I can plug in here, no power that could be to make a 0 as an exponent, right? That's not how exponents work. So we get nothing here. Those can't equal 0, so we don't get anything there. So we're going to go back to our values here. These are our critical values. These are the critical values that we're going to check to see for increasing, decreasing. Okay. So I have a -3/4 and a +1/2. Now I know these are fractions, but it's meaningless. Fractions are meaningless in this case because I can pick numbers that are less than the fractions or bigger than you can pick whole numbers, right? Just because they're fractions doesn't mean it's going to be harder. It just means those are their critical values. So now what I want you to do is find out where it's increasing. Where is it increasing? That's what we got to figure out. So on your own right now, finish it out. Where is it increasing? Where is it decreasing? We know it's doing neither at -3/4 and 1/2. Those are maximum minimums. Okay, so finish it out and give you a few minutes to do that. Okay, so remember, all I care about is positive or negative. I don't care what the number is. So you get a lot of e's and all that stuff. Don't worry about that stuff. Just worry about, is it going to be a positive or is it going to be a negative? I didn't finish it. I just plugged in. I plugged in -1. I plugged in 0. I plugged in 1. I didn't finish the problem. But I know probably a lot of you are seeing those e's and the powers and all this stuff and freaking you out a little bit. It's just all you're worried about, is it a positive answer I'm going to get at the end or is it a negative answer I'm going to get at the end? That's it. Okay. So I plugged in -1 to the original, or to the first derivative, and the top's going to be positive. -2 times -1 is +2. All these e's I'm not worried about, because all these e's are just going to be positive numbers. Okay, so e squared, e squared, e squared, e to the fourth, big deal. They're all positive numbers. Okay, because anything with a exponent like this is always going to be positive, because these are all squared, and e is a positive number. So I'm just more worried about these guys here. So this guy is going to be positive. Let's see. Yes. Squared. Okay. So we have, yeah, let me make sure I did that over here too. Okay. So over here, I have +2. So over here, I have +2 e squared plus 3e squared. And then over here, I have -1 squared, which is 1, times -8 is -8e squared. Oh, so it's going to change my answer here. The bottom's going to be positive, so don't worry about the bottom. Bottom's going to be positive. So now we're just combining like terms, because they're all e squareds. So I'm going to have negative, was it -3 e squared? So when I do that, that's actually going to be negative. So you're going to have a negative divided by positive, which is negative. So let me go down here and put negatives over here. Okay. That makes more sense, because on this one, I'm going to get a positive. So this one here, zeros cancel things out, or they make it 1. So the first guy, when I plug in 0, it's just going to be 0. Everything's just zeroing out. The middle term doesn't have a 0, just for the exponent, but that makes it a 1. And then the last term zeroes out. The bottom's just going to be 1, so it's going to be 3 over 1. So a positive divided by a positive makes a positive. And then when I plug in 1, I'm going to get the same exact answer I got for the first one. No, not the same exact. Close. This is going to be, again, so these negatives here, is that going to make the answer negative? A negative exponent, does that make anything, does that make the answer negative? No, it just makes the answer a fraction. It makes it smaller, right? So I'm not worried about these guys here. These guys here are going to be positive. Okay. So I'm going to get a -2 e to the -2 plus 3 e to the -2 and a -8 e to the -2. On bottom, I'm going to have a positive, because e to the -4 is a fraction. It's a decimal, but it's still positive. On top here, I combine like terms and I get -7. E to the -2. That's going to be a negative. Okay. Mhm. -3/4, -3/4, -3/4. So, oh, for the first one, -1. So -1 would be here. Zero's here. Mhm. Yep. Okay. All right. So going back to the original question said, where is it increasing? Increasing from -3/4 to +1/2. Okay. All right. Like I said, that was more of a first derivative. We didn't do the second derivative on that one, but it was important because it's got e's in it. And if you know anything about the test, about AP tests, is they like natural logs and they like e's. Okay. So finding derivatives of those is one of the big things. Okay. So anytime we can include one of those, I do, because like I said, there's not a lot, but there are some e's and natural logs. Okay. Okay. So we haven't done a trig one. So let's do this example here. Even though it's not a second derivative problem, I want to do a trig one because we haven't done one yet. Okay, so a trig, trig. So we got to use this. We got to find relative extrema. I got to find out where it's increasing, where it's decreasing. Same thing as the last one. It's just a trig function. Okay. So first derivative. Okay, find the first derivative. Don't look up here till you're done with the first derivative. Once you're done, we'll see if we get the same answer. Okay, so once you got the derivative, take a look up here, see if I got the same thing. Hey. Oh, is this from the? These are the reports. They may be totally different by the day, but those are the reports of everything that's left. Okay. Can I type the thing fast? Yep. Let me. All right. Okay. So first derivative. Okay. Now we got to set it equal to 0. Okay. Set it equal to 0. Okay. Then we got to solve, right? How do I solve this? How do I solve this? Because I can't subtract 1 from both sides, divide by something, like I can't factor, using, it's not a quadratic, it's not linear, it's not a polynomial, it's a trig function. So how do I solve this? Well, when I'm saying solve, what does that mean? What does solve an equation mean? Yeah, find x. There it is right there. So what do you mean by find x? Keep. There you go. To make it true, right? Right? Because anytime I say find x, there it is right there. Right? That's what people say. Trust me, I've seen that. I've been teaching long enough to say that. So when I say find the value that goes in to make it true, right? I want to find out the value that I plug in there, it equals 0. That's what I want to do, right? So with trig functions, they're kind of different. They're different. They're a different breed, right? So this is what I'm going to do. This is what I do. What I do is I'm going to add sine squared of x to both sides. Okay, that gives me two positives. So any value I pick, what has to be true about it? How is that going to help me solve it? Because if you have a different way, please tell me. But this is the easiest way I found how to solve these guys. I'm trying to make one side equal to the other side, right? That's what I'm trying to do. So where do I plug in values? Right there and right there. So what I'm trying to do, what number will go in there and there that makes it equal? Right? You can change the sine squared to this, and because if it's equal on the inside, it's going to be equal on the outside because I square the same number. So I'm just trying to figure out where that's true right there. That's what I'm trying to figure out. Where is this going to be the same value? So how do I do that? Pi over 4? Let's check it. Let's try pi over 4 here and pi over 4 here. Okay. So what is sine of pi over 4? Root 2 over 2. What is cosine of pi over 4? Same? That works. Yep, that works. Root pi over 4. So I'm curious because Sebastian had it memorized, right? Some of you might have it memorized. If you don't have it memorized, what should you be doing? This guy right here, which all of you have, right? This should come in handy. Anytime we do a trig problem and you don't have them memorized, or even if you do have them memorized and you haven't done it in a while, this is the guy automatically you should take out right here, especially if we're doing notes. Always have this guy handy because anytime a trig problem comes up, we're going to go to this guy, right? Some of you might have it memorized. Like I said, that's great. But if you don't have it memorized, that's why I gave you this. Okay? So every one of you should have this out. Because if you don't, I'm going to give you a lot of these on the test and you're not going to be able to use this. Because I'm going to be like, well, you didn't use it during the notes. Why are you going to use it during the test? You know? That's why teachers don't allow students to use notes on tests. Because when I'm asking, I'm like, what's the answer? What do we do next? Everyone just stares. No one looks at their notes. Right? And I'm like, well, if you didn't use your notes then, why are you going to use your notes on the test? Right? That's kind of the same reason why we don't use notes, right? So anytime there's a trig problem, pull those out unless you have them memorized. If you have them memorized, awesome, great, that's terrific. I don't even have them memorized. Good for you. I'm happy. But that's what we should be doing. So right when I pulled out this problem here, that's what I want to see. Okay, that's what I want to see. Right? So pi over 4 works. Pi over 4 works. Good. All right. So we got an answer. Is there another answer? Is there another answer? 5 pi over 4? 5 pi over 4 works as well. They both give me the same answer for sine and cosine. Is there another answer? Or is that it? That's it? Okay. So which one is going to be our answer? Yes. Yeah. Yeah. So I could have the positives and negatives, right? Yeah. So like what's another one? Give me an example of the negative one, Sebastian. 3 pi over 4. Go to 3 pi over 4 right now on your chart with your finger, right? One of them's positive and one of them's negative, right? But don't we square it? So in the end, it's going to be the same answer, right? So there's a lot of answers, right? There's a lot of answers. Yeah. That's what my next question was. Okay, so which of these can we use? All of them, some of them, none of them? Okay. Just like Emma said, let's look at the interval. The interval is what we want to look at. Okay, that's going to determine our answer. So anything outside of the interval, we cannot use. So all of them that are bigger than pi over 4 or pi over 2, sorry, we don't want to use. I'm glad you brought them up. That's important. But for this problem, we're not going to use. Okay, so this guy here and this guy here, we can't use for this problem. It's true. You're right, 100%. What you said is true. It makes it equal, but we can't use that. Okay, I'm missing one though. Which one am I missing? And it's not on your chart. Which one am I missing? And why am I missing it? Not 0. 0's on your charts. It's not 0. Negative pi over 4. What do we know about? What do we know about trig functions, especially sine and cosine? They repeat and repeat and repeat, right? Do they start at 0? No, they go backwards too, right? So whatever happened on the other side on the positive side also happens on the negative side. Okay, it's just not on your chart, right? But if we're doing the sign of the unit circle here, watch. If I got the unit circle, I can go positive, right? Positive here, right? Positive. Those are the values you have on your chart, right? But I can also go negative, right? To give me negative angles, right? And then when I graph it, so let's see, here's sine. So it's going to do this, right? Move it over a little bit. Right? It's also going to do this on the negative side. Okay. So the value at pi over 4 is right about here. Where's the value at negative pi over 4? Right about here. Why are those the same number? One's positive and one's negative. Why are they the same number? They're squared, right? They're the same absolute value. They're the same absolute value, right? They have the same absolute value. So when I square them, they're going to be the same number. So that's why negative pi over 4 is there. Okay. All right. Okay. So what I want you to do now is, where is it increasing? Where is it decreasing? Where is it increasing? Where is it decreasing? So finish the first derivative test. Finish it out. Tell me, where is it going to be increasing? Where is it going to be decreasing from in the interval? Only within the interval. negative pi over 2 and positive pi over 2 and 0 because they're left of those. But, you know, you can check pi over, let's see, in between them, you can check pi over 6. Greater than, you can check pi over 3. Greater than pi over 4, you can check those, but those are the ones I checked because those are the ones I chose. Okay, as long as it's a value within the interval that's greater than pi over 4, in between negative pi over 4 and pi over 4, and less than pi over 4. Okay, and this one has brackets around the pi over 2's and negative pi over 2, so that means I can use those. If it was parentheses, I couldn't use those. Okay. Again, I just care about if it's going to be a positive or a negative answer. Okay. So, first one, negative pi over 2. It's not on my chart. It's not on my chart, but guess what? It's going to give you something similar to regular pi over 2. Regular pi over 2 for sine is 1, positive 1. So this guy is going to be negative 1 because it's over here somewhere, right? Positive 1's up here, negative 1's down there. But when I square it, right, it's going to be positive 1. Okay? But then I got to multiply times the negative in front, so that makes this negative 1. So it's actually negative 1 here. This whole thing here is negative 1. Because order of operations says I do exponents first and then multiply. Okay? So this whole thing right here is going to be negative 1. And then cosine of negative pi over 2. Well, cosine of regular pi over 2 is 0. So it's just still going to be 0. 0 squared is 0. So you're going to have negative 1 plus 0, which makes a negative answer. Okay, so negative is going to be here. All right, 0 is on my chart. So sine of 0 is 0. Squared is 0 times negative 1 is 0. So all of this guy is going to be 0. Cosine at 0 is 1. 1 squared is still 1. So you have 0 plus 1, which is positive. Okay, last one, pi over 2. Pi over 2 is going to give me the exact same answer as negative pi over 2 because it's squared, right? Pi over 2 for sine, again, is 1. So this guy is going to be 1. Squared is 1. Times the negative in front makes a negative 1. This over here is still 0. So it's negative 1 plus 0, which equals negative 1. Okay. All right. So knowing that, we know it's going to be decreasing before negative pi over 4. And then at negative pi over 4, it's going to change to increasing with a positive slope. And then after pi over 4, it's going to go back down to a decreasing. So let me get another sheet here so I can wrap this question, so I can answer the question, because I haven't even answered the question, relative extrema. So we have a relative maximum at x equals pi over 4. And we have a relative minimum at negative pi over 4. Okay. All right. Okay. Let's do one more. I'm going to give you guys one more to do. Let's see here. let's see. Actually, you know what? Do this example here. We'll do the next two. So this is what we're going to do. I want you to do this example right now. The next two we'll do tomorrow. And then the rest, we're not going to take the whole block tomorrow to do. And then the rest of the time, I'll give you guys some time to work on your assignment. Okay. So half of the clock class will be to work on the assignment. And then the notes I gave you today, we'll push those to Monday. Okay. Oh, what's no? Oh, it works. I just don't think there's any stuff in it or batteries in it or